Alright, so let's take a look at solving a system of equations using this graphing method. This one's not so much real world like the first examples, but it's just how we do this mathematically, how this looks like as a math problem. Alright, so what I've got here is one set of data represented by this equation in blue, and this other set of data represented by this equation in orange. And the idea, once again, is we're just going to graph these two sets of data, but we're going to put them overlapping on the same graph. All right, now, luckily, these are both in slope-intercept form, so let's take a look. R1 in blue, we've got a y-intercept of 2, and it looks like we've got a slope of -1, so let's bring that invisible 1 back out, which, if I do rise and run, it's going to be -1 over 1. All right, so that means on the y-axis, I go to a y-intercept of 2, and then my rise is -1 and my run is +1. So -1 over +1, -1 over +1, so on and so forth. So the equation in blue is represented by this line right here. See if I can get it as straight as I can. Like that. Okay. And be sure to get your lines as straight as possible because since we're looking for this point of intersection, accuracy is important. Alright, so now all we have to do is just do another graph, but we're going to use the same grid. We're going to graph this data in orange, y equals 2/3 x minus 3. So here the y-intercept is -3, which would put it right here. The slope is rise 2, run 3. And if we graph it, it looks like this. Big, long, double arrow going both directions. It's a little faded. Let's try to do a little better. Alright. So now what we're looking for is what we call the solution to the system. It's the one piece of data that's the same in both the blue and the orange. Well, physically on our graph, what that means is that we're looking for the point of intersection. This is what we call the solution to the system. In which case this has the coordinates, let's see, 3, -1. Okay, so what that means is this. This means that this is the only pair of xy coordinates, or xy answers, that works not only for this equation in blue, but it also works for the equation in orange. Okay, and that's how you check your answer, because who knows if I did this crooked, if my ruler was a little bit off, or if, this just slightly intersects maybe at 3.1 or something. So to test my answer, what I do is I go back and I do a check. Okay, and I start off with just one of the equations. I'm going to take this one in blue, and I'm going to drop it down here. And when I write it, what I'm going to do is I'm going to first write it out. But then what I'm going to do is I'm going to take out x and y. I'm just going to leave blank sets of parentheses as placeholders for where x is and where y is. Now, I take my answer. 3, -1. Well, x is 3, y is -1, and if I've done my graph correctly, then these numbers should work out in this equation. So let's put 3 here, put -1 here. So when I do the math, on the left side I've just got -1, and on the right side I've got -3 plus 2, which is also -1, which checks out. Now, does that mean it's the solution to the system? No. What it means is it's a solution for this blue line. We also need to check to see if it's a solution for the orange line at the same time. So let's take that equation, bring it down, y equals 2/3 x minus 3. And once again, take out y, leave in some placeholder parentheses, and take out x and do the same thing. Alright, take your same solution to the system to check it there. X is 3, so that goes right here. Y is -1. And so now, when I simplify this, I get -1 equals, let's see, 2/3 times 3. 2 times 3 is 6, and 6 divided by 3 is 2. And then 2 minus 3 is -1, and this one also checks out. Now this is just coincidental, they both equal -1. That doesn't have to happen as long as what you get here, like 4 equals 4, 12 equals 12, as long as these numbers work in both. Alright, so we've just confirmed that this is the solution to the system. We did the graph right, We checked our answer, so mathematically, this is the only pair of numbers that works as an answer for both equations. There's no other pair, there's no other set of numbers that can work for both of these at the same time.